Hi, my name is Matt Zeiler, and I'm the founder and CEO of Clarify. So, welcome today. I'm going to talk about manufacturing and AI technology and how it continues to deliver benefits to the world. So, thanks for joining me at AME Dallas 2022. I'm going to start off my talk today by giving a broad overview of what is artificial intelligence and machine learning. Then I'm going to cover why you should care, the economic impact, and how AI applies to manufacturing. I'm going to then go through some examples and demos of industrial applications of machine learning. And then I'm going to wrap up with what is an AI platform that can really solve big problems across a large organization. So AI and machine learning. So let's start with AI. AI is the broadest term, and it really is any technique that makes computers mimic human intelligence. It could be simple logic, if-then rules, trends over time, decision trees, and that includes machine learning. So machine learning is a subset of AI that really learns from data. Repeated patterns in data are extracted in order to create a model that can then be used to recognize those same kind of patterns on new data. Finally, deep learning. This is a subset of machine learning, and this is where you're seeing most of the interesting applications of AI today. And it is really based on neural networks, which are algorithms that are meant to emulate how the brain works. So we all have neurons that fire in the brain, and neural networks are structured in a very similar way. And as they're exposed to data in a repeated fashion, they could be updated through what's called backpropagation to actually update all those parameters, all those neurons of the deep learning algorithm in order to recognize very sophisticated patterns, much more sophisticated than any human would be able to code into an algorithm directly. And that's why it's so powerful. And you're seeing two areas where they're having really big impact: computer vision and natural language processing. So computer vision are basically your eyes, and natural language processing is your ears and your comprehension of language. And these two fields are, with the power of deep learning algorithms, are now allowing computers to see and read and hear. So it's a really incredible time that we're in, and we're able to apply these techniques to solve really powerful problems that have typically been too difficult to solve before. And that's why you're seeing it go mainstream. We've all heard about AI, but now as a business operator, you're definitely thinking about how you can apply it. And in this survey covered by a company called Figure Eight, nearly 1/3 of the respondents said that their AI budget is $250,000 or more, with some of them spending upwards of $5 million. And that's just within a single business unit. Across all industries, people are really pouring in resources because they see AI has become a true differentiator and a competitive advantage. And that's why it's made its way into the boardroom. And it's a C-level, VP level, and above types of roles are really thinking about how to deploy AI across the entire organization and do it in a consistent way. So 60% of business line owners said that their organizations are actually behind when it comes to AI. And 49% of technical practitioners feel the same. So it's a really powerful technique. Everybody at the executive level knows that they need it, but people are behind in implementing it. So hopefully today we'll see if we can speed that up. And this is going to have a huge impact because AI is honestly going to transform every possible part of the economy, including manufacturing. The global AI market value is expected to be 267 billion by 2027. And that's going to contribute about 16 billion in global economy impacts by 2030. And it's going to have a big impact on jobs, but it's not just going to eliminate 85 million jobs. It's actually going to create more new jobs, 97 million by 2025. That's a huge, exciting aspect of taking on new technology like artificial intelligence. And we're all familiar with it today. We speak into our phones, into our cars. There's over 3 billion voice assistants now in use, and that's powered by this deep learning that I just talked about. And there's going to be 8 billion by 2023. And that's just one type of AI technology. You log into your phone with your face. That's also deep learning, artificial intelligence. And about 2/3 of all Americans believe that self-driving cars are actually safer than regular cars. That's a very difficult algorithm to get right, and Americans are already trusting it. So that's really exciting because the future is only going to get more and more accurate. And about 25 different countries around the globe are actually working on that problem of autonomous vehicles. And they think that that industry is going to be worth about $600 billion over the next 5 years. So these are just some example stats that show that this is a huge problem and a huge opportunity that AI presents. So I urge you all to be thinking about it and listening today to see how you can capitalize on it. And it's going to have a huge economic benefit. So in manufacturing, we think about quality a lot. You want to have the highest yields on your manufacturing line, and we can automate that with image recognition for visual inspection, looking for faults. That can increase productivity by up to 50% and decrease the defect rates by up to 90% compared to human inspection. The other aspect is AI doesn't get tired. It's always consistent. It doesn't get angry or frustrated. It's a much different aspect to plan for than planning for humans. You can also leverage it to recognize and predict machine failures before they happen, either based on time series signals like temperature sensors or other types of sensors, audio signals, or visual cues. So it turns these IoT sensors into a much more robust device. And that can increase asset productivity by up to 20% and maintenance costs reduced by about 10%. You can also make humans more productive. It's not about eliminating humans, but having humans in the loop and interacting with AI can make them more productive by up to 20%. You can also decrease the scrap rates and testing costs that are across the different machine groups, yielding about 30% detraction. So these are some stats from McKinsey just last year on the economic impacts of AI when applied to manufacturing. And so let's look at some of those use cases that impact these these numbers. So let's start with image classification. You can classify different types of parts automatically. This is something that actually is built into Lowe's, the home improvement chain. So you can actually test out both the classification and the next use case, image similarity. So using an image as the query, you can find stuff that looks visually similar. So in the Lowe's app, you can try it out right now, take a picture of something that Lowe's may sell, and it'll automatically retrieve the most similar looking products. So it could be a part, it could be a tool, it could be outdoor furniture, and you don't have to guess the keywords that would be important to finding that piece of content or product. So in manufacturing, finding these parts, finding them with an image as a query is a really powerful technology. You can also recognize different defects. So looking, and I'll show you some demos of this today, looking for cracks, looking for defects on screws. You can look at anomalies in audio signals over time, like an engine changes or a fan sound changes. That can be detected automatically and indicate that maintenance should be done before a bigger disaster happens, either safety risk or a bigger cost overrun because you skipped an opportunity to maintain heavy equipment. You can also look for potential points of failure. Maybe it's a crack on a bridge or a truss. You can spot these things early before they become big issues. And you can even do things like the surface detection for paint, weld, corrosion, rust, and maintain these equipment before they become bigger issues. Going on to the next use case, part and serial number determination. So if you have barcodes, you can scan those. If you have serial numbers, you can read those, even if they're not in standard labels. So if they're engraved into the text or even handwritten, you can start recognizing these things automatically with AI. And then thinking about text applications, you can process all your maintenance logs to see if there's any urgent requests or spot trends over time, getting analytics out of your logs. You can even translate those between different languages. So if you're working across a global workforce, you can all stay in sync. So let's dive in and take a look at some of this technology in action. So in this first scenario, we're looking at scans of rolled sheet metal and looking for defects in that sheet metal. And this is our product here. You can see it's showing a bunch of different examples of this type of content. And then on the left-hand side, we've categorized them into crazing, inclusion, patches, pitted surface, rolled in scale, and scratches. So if we go ahead and look at some of the inclusions. So these are examples that have inclusions in the metal. And this is all labeled to contain inclusions. So if I look at this, it's showing that I've labeled this manually as an example of inclusions. Now, I've trained a model to recognize this. So here, it's actually showing the predictions that this is 100% confidence, that's what the 1.0 score means, that this contains inclusions. So if I show another example, it'll actually run the predictions again, 100% confident. And so it actually has learned how to recognize and identify these types of defects. We can take a look as well. Let me update the query. So here, now that I've trained a model, I can actually search for those defects automatically. And this is actually searching for what the AI is actually thinking and contain patches in the sheet metal. So I didn't have to tag all these examples. It's actually finding them out of my whole collection. So this is really exciting because you could have a stream of the sheet metal being analyzed, looking for quality, and in real time, in a fraction of a second, you can actually spot these defects and send an alert. And once you collect a lot of data, maybe you have archives of stuff that you don't want to predict in real time, but you have a huge amount of data, it makes search over that data possible. So you can see kind of analytics over how many different examples of patches were actually recognized over time. So that's one example where we're looking at sheet metal on an assembly line. Now let's take a look at a second example. So here are screws. And there's a variety of different screws, different orientations, so it makes this problem more difficult. But you can imagine dropping screws on a white sheet of paper and then looking for defects to see how your quality is performing. And so the concepts in this model that are now trained to recognize these defects are simply defect or no defect. And if I drop into some of these examples, let's take a look at how that model performs. So what you're seeing on the right-hand side is actually our model loading up for the first time. When a model within the Clarify platform is not used, it actually goes into cold storage. This is really important because it saves resources, compute and memory resources. And it automatically brings it up out of cold storage the first time it gets a request like you just saw. And now it's actually predicting with 99% confidence that this is the defect. And compared to the last example, which was a classification model, which means it's going to classify the entire image to have some of those things like inclusions or patches, this model is called a detector. And that allows it to detect and put a bounding box over the specific area that it is trained to recognize. So in this case, it recognized a defect there. Let's move on to another example. You can see because that model is out of cold storage, it predicted it in about 100 milliseconds. Go into another example. A defect up on the top of the screw, on the side, or even the end. So all of these are trained into one model to recognize these defects, and it's doing it with incredible levels of accuracy. Let's check out another example. So we looked at a classification model, a detection model. Now we're going to look at what's called a segmentation model. So this is actually segmenting out cracks in the data. So these are different pieces of material, concrete, and other types of hard surfaces, and they have some cracks. So when I visualize what's being predicted by the model, it's actually highlighting those cracks automatically. We'll go ahead and look at a few other examples. This again is going to pull up this model, which is coming out of cold storage, and you can see I don't have to actually hit any deployment button as it's cycling in and out these models. So now that I got this model loaded, it's actually recognizing these cracks. This is a very tedious thing to do, by the way. So if a human was to draw this kind of crack, it would take a significant amount of time to get that level of accuracy. And the model, you can see, is doing that in a fraction of a second. So this segmentation model lets you pinpoint very specific details, much more than a bounding box like you just saw in a detection model. So these are kind of some close-up examples, but let's take a look outside for some predictive maintenance use cases. Let's say you have insulators deployed out in power lines, and you want to detect some of the issues that can happen with them. They can have broken ceramics. Here we're looking at flashover damage. It's been categorized as a few other broken ones. And these are predictions. These are not labeled. These are actually predictions from the AI. So imagine you change your maintenance to fly a drone up into these hard to reach locations, hard to have humans and very dangerous to have humans close to these. Fly a drone, capture the data, and then recognize the issues at scale. you can imagine drones just flying down the power lines, looking at all of these insulators and monitoring them over time. Now let's take a look at anomaly detection. So here's an interesting use case where a pill manufacturer is creating pills, and you can see these are not the types of pills you would expect out of any kind of bottle at home. They all have chips or other types of defects. These ones are dirty, and then there's a bunch of good ones that you would normally expect. And so here we've trained a model that actually doesn't require a set of labels. It's actually looking for uniformity across all of the labels. So it would expect the pill to be in the middle of the image and fully round. And when it detects that there's some defects or anomalies, is the correct word, it's looking for anomalies compared to that kind of consistent view. And so here, obviously, this chip is an anomaly. Unfortunately, our UIs don't yet render this. This is one of our latest AI models, and the UIs will handle it soon. But if you look at the output of the AI model, it is actually this type of image down here. So compared to that example here, this is the output of the AI model. And so where it's dark here, it's saying this is not right. It's kind of pushing it negative, and that's why it becomes black. It's saying this is an anomaly. The rest is actually pretty consistent. You should be kind of gray everywhere, but when an anomaly happens, it shows up in black. So that is an interesting model because you can just have a bunch of data that you expect to be consistent, and it'll automatically find those anomalies for you. And so I showed you a few different examples. These were all built from our sales engineering team, but let me show you what it looks like to build something on the fly. So these are my personal pictures, and I can search for things automatically. As data is uploaded to Clarify, it gets indexed by AI so that you can actually find your content very easily. And we can recognize common things like dog. You can see here there's a lot of pictures of my high school pet, the black dog, but there's some other dogs in here. And so if I want to teach the platform how to recognize something new, like my dog or those inclusions in the rolling sheet metal, I could type in literally anything. I've already done this demo several times, so Rolly's actually been typed in before, so we make that a little convenient for you. So I've labeled 3 pictures of Rolly. Now I want to go ahead and create a model. And you can see at the click of a button, I can go ahead and do just that. So I'm going to give this model a name, and I'm going to say I want this model to recognize Rolly. Now the rest of these settings are more for advanced users, and the defaults are chosen wisely so that you can basically ignore them. Now that I've created a model, I'm going to go ahead and train it. So now it's going to iterate over those 3 images to try and learn how to recognize my dog. And there we go, it's complete. So in a matter of seconds, I just taught the system how to recognize my dog Rolly. And immediately after training, I can actually search over my huge data set of personal photos to find all the pictures of Rolly. If I go into these and look at the model predictions, you'll see this is one of the images I labeled. That's why it has a green check. And it's 100% confident that this is Rolly. I go to the second image, also labeled and 100%, third image. Now if I go to the fourth image, I did not label this Rolly, it's still 100% confident. So we just taught the system how to recognize my dog and recognize it in new data. And you can see I don't need a PhD in AI like I personally have, but I also don't even need to be a developer. You can put the power of AI into the domain experts' hands, the operators, the maintenance professionals who actually know the differences between these things, these intricacies, and allow them to teach the AI. Once the AI is taught, here's an example with text data. So if I go into these, I get little snippets of research papers. And in this example, we're categorizing these different types of concepts. Now that this model has been trained in the past, I can go ahead and view detailed accuracy measures. So as your domain experts are training models, you can see what the recall rate and precision rate, overall accuracy scores, how many false positives and false negatives it makes. You can see what categories are confusing as well. So in these research papers, physics and chemistry are often confused, and so forth. So we give you the analytics as well so that you can really evaluate the performance of your model before running it in production. And all these even modify dynamically as you tune the threshold in preparation for running in production. Another interesting text example is language translation. And we have a whole variety of pre-trained models off the shelf ready to go for about 99 different languages to and from English. So you can get maintenance logs from around the world. As an example, this is coming in Japanese, and we're predicting a defect was found on the left side, which I believe is correct for that Japanese sentence. So these are all ready to go. And if I drop into our community, you'll see we have about 500 different AI models off the shelf ready to go for a variety of different use cases. So you can check this out. It's all public at clarifai.com/explore. Now, let me go back to the presentation, and we'll wrap up with a little bit more details about an AI platform. So you may be thinking about within your executive team, well, AI is possible. It's really exciting, really important. Should we build it ourselves, or should we buy something like Clarifai or other software that does AI? Well, we urge you to think about the level of effort. Whenever you start down the path of building something like artificial intelligence, you have to think about hiring, building the team, ramping them up on the problem and the AI, getting your data together. That typically takes 18 to 24 months. And often comes with cost overruns, an increase in time to value. It takes a long time, a lot longer than you typically expect. And then the end result is very often that data scientists like to play around. They like to experiment. That's their nature. And they do it on their laptop, and the quality is not very good. It never really gets into production. So you spend a lot of time and energy for something that is actually not going to impact your customers, and it leads to a bad customer experience. And it also is an opportunity cost. You could have all these bright minds actually do something that differentiates your product, rather than have them reinvent the wheel trying to build something with some AI infrastructure. If you end up buying, it can really give you a predictable cost. We can estimate your volume up front and talk about an annual contract for multiple years, so you have predictable cost. Drastically reduces your time to deployment. Like you saw with some of those pre-trained models, you can literally sign up for clarifai.com and within minutes be up and running at production scale with them. And it reduces the level of technical development and support requirements that are needed for AI. It's a new type of technology, and running it at production scale 24/7 is a difficult task in itself. And so it's going to scale with your business needs and also keep up with the state of the art. So with Clarifai's community, we have the world's AI. We've actually coined that phrase. It's the world's AI of state-of-the-art artificial intelligence available at your fingertips. And we have a dedicated research team with PhDs in AI like myself, and the team collectively has over 170,000 citations, which means we are really keeping up with the research community to make sure the best AI is available in our platform. Now, when you think about adopting a platform, you should think about these types of questions. I won't go through these in detail, but think about the data, think about the devices that are creating that data, think about how that data is going to be labeled. Then think about how you're going to be actually training models and who's going to be doing that on your side. Is it a data scientist? Is it just a developer, or is it the domain expert, the operator? You need a platform that has the fine-grained controls, the APIs, so that developers can hook them up, and user interfaces that make it really easy. Then you got to think about where it's going to be running. What are your deployment options with an AI platform? And then you should have to always consider measuring performance, especially in production, because once you're on the real world data, there could be aspects like data drift. Your environment changes over time. An example of this I like to use is COVID. So about 3 years ago, nobody had COVID-19 in their vocabulary, but then all of a sudden the data changed. That became part of everybody's vocabulary. And if you had AI models recognizing that, they wouldn't understand unless they were adapting to the real world changes in the environment. You should always align with the product roadmap. You should see what kind of onboarding and training to set your teams up for success. And obviously, data security is a crucial aspect, and how much of a lift is it to deploy the solution, and of course pricing. And so we have the AI lifecycle, complete end-to-end. We have the AI lake to really collaborate and facilitate working as a team or as a community across the planet. We can run it wherever you need to, thanks to our AI fabric. And we have the AI experts that will pair with yours in order to solve your business challenges. So thank you for joining today.